So before we do a couple of examples of comparing the three different types of relationships, linear, quadratic, and exponential, I just want to again highlight and summarize how we recognize an exponential relationship. So first off, if we're looking at an equation for an exponential relationship, it says the equation will be in the form of y is equal to some constant, okay, times b to the exponent x, or to the exponent of some variable. Okay, and so a and b are both going to be positive numbers, but b cannot be equal to 1. Okay, so b cannot equal positive 1. So in a couple examples, you might have 3 to the exponent x, or you could have y is equal to 2 times 3 to the exponent x. Okay, and again, the key here is that the exponent, or the highest exponent in the equation, is the variable. Inside of a table of values, the differences are not going to be constant. Okay, the first differences won't be constant, the second differences won't be constant. However, the ratios of consecutive y values are constant. Okay, so if you divide one ratio by the next y ratio, you will get the same number, regardless of the direction you're going, if you're going up the table of values or down the table of values. And then lastly, the graph. Okay, uh, in an exponential relationship, the graph is a curve. Okay, that is almost horizontal at one end, either the left or the right, and then it increases or it decreases rapidly to the other end. So if we look at the example here on the left, this is an example of an increasing exponential function. Okay, and then the example on the right, you see it moves down from the left to the right. So this is a decreasing exponential function. So that's our decreasing exponential function. So we'll do a couple of examples just to make sure that we're all on the same page. So if we're looking at first the graphs, and there's 6 graphs, we need to identify them as either linear, quadratic, or exponential. So here on the left, we got a curve, almost vertical at one end and almost horizontal at the other. So this one is an exponential curve. Here we've got a straight line. Well, that's going to be linear. Okay. Here we've got a U shape, we've got a parabola, so that's going to be a quadratic relationship. Okay, because parabolas are always the shape of a quadratic equation. In the next row, we've got again a line, so that's going to be linear. In the middle here, we've got a upside down U shape, that's parabola. So, oops, this is actually going to be a quadratic. And then finally, we've got an exponential curve that's almost horizontal and then gradually moving to the vertical. The other way that you can look at it is just simply by the equation. So what's the highest exponent in this equation? Well, here the highest exponent is positive 2. So this is going to be quadratic. In the middle, the highest exponent is going to be a variable. So because it's a variable, this is going to be an exponential equation. And then on the right-hand side, the highest exponent is actually a 1. Okay, so when there's no exponent that's written, the implied exponent is positive 1. And so positive 1, or rather an exponent of positive 1 indicates that it's going to be a linear relationship. Okay, so that's a good quick summary of how to look at the difference between a quadratic, a linear, and an exponential relationship.